Greetings everybody. This video will hopefully explain to you how to do lab number 3, which is Newton's second law, uh, where the force is constant. Let me bring up a file here. And so what's going on is, we'll get to the simulation in a second. Well, Newton's second law states that the sum of the forces acting on an object equals the mass of that object times the acceleration. Now, it's a vector equation. You can have one or more forces acting on an object. And remember, force is a vector. Um, so it's actually a vector equation. However, in the simulation, the applied force is going to be in the positive x direction. So Newton's second law becomes F equals ma, or A is equal to F over m, which is just rewriting as A is equal to F, then parentheses 1 over m. That's equation 1. Okay. Now, in this lab, we're going to keep the applied force constant, and then we're going to increase the mass in increments from 40 kilograms to 380 kilograms. And for each of those masses, and we'll get to that in a second in the template, we're going to have two values of the acceleration. One value that we simply read from the simulation, and the other value that we calculate from equation 1. A is equal to F times 1 over m, or F over m. So we're going to have one column which will give us the simulation values, and the other column which we calculate using equation 1. Well, why are we doing this? Well, if we graph equation 1, if we graph A versus 1 over m, and when we say versus, it's understood when you're graphing any two quantities in the language of math and physics, when we say A versus 1 over m, that's the y-axis versus the x-axis. So when we say A versus 1 over m, A goes on the y-axis, and 1 over m is on the x-axis. That's standard in math and physics language. A versus 1 over m means A is on the y-axis, 1 over m is on the x. Well, when you graph A versus 1 over m, that graph is going to be linear, which means that the slope of that graph should equal the applied force F. And in the video, I'll show you how to set up, how to have Excel do the graph. I'll probably break this video into 2 or 3 parts because doing the graph in Excel is not difficult, but if you haven't done it before, it might seem a little bit daunting at first. But believe me, it's really very straightforward. But that's what we're doing. And we're doing the same thing twice. For sheet 1, the applied force is 25 newtons, and for sheet 2, the applied force, I believe, is 82 newtons. And again, we're going to get all the values, graph A versus 1 over m. The slope of that graph is the applied force F. And then we're going to do the percent errors and the percent differences. All right, let me go ahead and go to the template. Okay, here's the template. Obviously, replace my name with your name. And notice I've already got, for sheet 1, here's the constant applied force of 25 newtons. Here are the mass values that we're going to enter into the simulation. Okay. Then again, we're going to get the acceleration, just reading it off from the simulation, and then the acceleration is calculated by equation 1, which is Newton's second law. Then we're going to graph A versus 1 over m. Well, excuse me. In Excel, when you want to graph, in other words, A versus 1 over m. A is on the y-axis, 1 over m is on the x. Well, the default in Excel is when you're graphing two variables, or two columns of data, by default in Excel, the first column is the x-axis, 1 over m. The second column is the y-axis, A. So that's why I'm going to just take the simulation values that I get in column E, and I'm just going to copy them over to column J. And then I'm going to, now, then again, the slope of that graph, how to do that, we'll get to that in a minute. The slope of that graph is going to be the applied force. So here is the applied force from the simulation, which we set at 25. I just copy that value there. Then here, see it says Excel. This is going to be the slope of your graph. Now with the accelerations, we're doing a percent error. We're using column F, the value for A obtained by the second law. We're using that as the accepted value and simulation as the experimental. Now for the force, we're not doing a percent error, we're doing a percent difference. So we're going to do the percent difference between L6 and M6. And the percent difference between any two numbers is simply the difference between the two numbers divided by the average of the two numbers. Then just multiply that by 100 to get a percent. So that formula I've already entered into cell 06. And then we're just going to sheet 2. We're doing the same thing for an applied force of 82 newtons. And again, I've already got the formula for the percent difference entered in. And so it should update itself automatically as we enter our values. I don't know why it's giving me 200 there. And oh, it is. Okay, yep, 200. That's copacetic. All right. So let me check the time here. Okay. So now let me go ahead and bring up the simulation and show you how to get all the values. So click here and bring up the simulation. And we want, okay, it's forces and motion basics, and we want to go over to acceleration. So click on it once and click on it a second time. And here it is. Well, and what's going to happen is this little orange colored stick man, he's the applied force, and he's going to push on this crate, and we can stack objects on that crate. That's how we change the mass. So what you want to do is we want to over here in this square, we want values, masses. We don't need the speed, but I like to see it. And of course, we want acceleration. Now notice here for friction, we don't want any friction. We want to set it down to make sure you're on none. The first time I ran this, I hadn't gotten all the way to 0, and it messed things up. So make sure you're down at none. Now here, this dial down here, you can vary the applied force. We want it to 25, but somehow with this little blue tablet here, when you drag it, it goes back to 0. So we have to go ahead and just click here, and I want 25 newtons. Okay, now notice right now the mass is 50 kilograms, and he's pushing on the crate. See, the speed of the crate is increasing, but its acceleration is constant. Well, what we want to do is we simply want to fill out the spreadsheet for these values of M. We want to go from 40, 50, 80, 100. They're not even increments simply due to the nature of the simulation, but that doesn't matter. We just want to get the acceleration for those values of mass. So for example, let me go back and do 40. So, and it's a little bit of a tedious process, but you'll figure it out. So I'm going to get rid of that crate. And notice the mass of the girl is 40. So I'm going to put her there. Now notice when I've moved the crate, the force went back down to 0. So I've got to bring it up to 25. Not a big deal. Well, a little bit tedious, but it is what it is. So now notice, the applied force is 25. There's no friction. And notice right here, acceleration, 0.63 meters per second squared. And notice her speed is increasing. Though we don't really care about that. I just think it's sort of interesting. So let me go ahead and, you can pause the simulation if you want. It doesn't matter. And I'm going to enter 0.63 meters per second squared for the acceleration. And that's from the simulation, 0.63. Now I'm going to go ahead and pause the video. I just have to do all these other increments of mass. 50, 80, 100, 140, 150. And, you have to play around with it a little bit. But now I want to go back to 50. So I need to put 50 here, but then get rid of the girl. And now notice I'm still at 25 newtons. My mass is now 50. But be careful. You want to restart the simulation. See? And now the acceleration is 0.50 meters per second squared. Go ahead and enter that. You get the idea. And now the other values, I'm going to go ahead and pause this video while I go ahead and get all the other values. I've got to do 80 kilograms and 100, 140, 150, 180. I'm going to just get all the simulation values for the remaining masses. So let me pause the video for a second. Okay, so what I've done is I've simply went to the simulation and I got all the values of the acceleration for the masses. Okay, now we'll worry about the percent error probably in the next video. Let me go ahead and let me see what this is. Okay, so now we want to create a graph of A versus 1 over M. So I've got my mass here. Okay, the mass is in column D, starting with D6. So I need 1 over the mass. So I need to go ahead and fill this column. So what I'm going to do is, remember, the values for the mass, they start in D6. So all you have to do in Excel is in the cell type in the following. Equals, then I like to use a space, and then left parenthesis, and then 1 divided by, and the first entry is D6, and then close parentheses. Now then you click on the check. That's Excel language for, hey, it's cool. Notice, obviously 1 over 40 is 0.025. Now I'm going to go ahead and simply take this formula and see when I have the crosshair, just drag it down to the bottom. So Excel is now calculated the 1 over M values. Remember, that's going to be the x-axis of my graph. Now for the simulation values, I'm simply going to take these values, I'm going to do copy and paste. So there, now I've got, so columns I and J, those are the columns that I'm going to graph. And for columns F and G, for the acceleration obtained by the equation for Newton's second law and the percent error, we'll get to that in a little bit. So right now you should all be able to go to the simulation and get your values of acceleration for all the different masses. For example, to get 380, the last one, you go, there's 200, 300, the man weighs 80, but now remember the force went back to 0, just go up to 25. Oops. And then you got to start it. And see the simulation saying that the acceleration is 0.07 meters per second squared. That's where I got, that value. All right, so let me stop this video and post it, and then in part 2, we're going to actually graph A versus 1 over M. I'm going to show you step by step how to create the graph in Excel.